second answer is it's going to be for a point dipole in a minute. And the way you get the dipole unit is I times the area to make that M. What are you eating?
Matt gives it's my birthday, Dr. Antonosa.
Happy birthday! You're 21?
I'm 22.
22?
And this is my gift.
God, I have shoes older than you.
Well, you know.
Yeah, I should get them replaced.
They're not your running shoes, are they?
No, they're not running shoes.
Do you guys use? Have you ever heard of those running shoes? The ones that like are like foot shaped. That you stick your like toes in the different it's like foot shaped, so it's supposed to mimic like running barefoot.
No.
Have you heard about it?
I've heard, Nike had a shoe a few years ago called the Nike Free.
Yeah.
And that was just not much to it. It was almost like running barefoot.
Yeah. Well,
I tried those, but I didn't like them.
These ones are supposed to
I've never even seen them.
They look like feet, so each toe goes in a different one.
Yeah.
Yeah.
Huh.
I want to get them just to work on my feet when I run, but.
Well, your feet will work if you just run.
Well, I know, but
if they're not working, you aren't going to run.
No, but my ankles are messed up, so I'm trying to
And here's the question. Here's the answer to your question. He wants to be able to group this into the whole idea in there is to your being able to recognize that IA squared is a point dipole, and you call that M, and there it is. The third part of this guy, and of course that's K hat. I didn't write it down.
Oh.
And he wants you to compare it to B, which he gives you in part C in the notes as B is equal to.
Oh, you didn't have to find it again. Oh well.
It's in there. In fact, I'm writing it down for you. Just
Yeah, we had a hunted down.
2R hat
I just did it again.
cosine theta, but you don't want to do it again. That's too much work. Sine theta.
Too late.
But there's physics behind this. There's physics. This is why I do them. Because you missed this and there's physics in it. Okay? This is in spherical coordinates with a point dipole. Okay? At the origin, right?
Well, that, yeah.
If you're up here, you're at theta equal to 0. When you're up here, R is equal to Z. So now what I can say is R hat, well, let's do this piece by piece. This is mu naught M over 4 pi Z cubed. This is 2. You're pointing straight up. That's the radial unit vector, yes?
Yep.
That reduces to K hat along the Z axis, so that's K hat. Cosine theta is 1. Sine theta is 0.
Yep.
Whoop, there it is. That's the first one.
You know who said that?
Tag team.
There it is.
Right?
Good job.
Thank you. All right. 814.
You're cooler than you look.
Oh, wow. Whoa. Yeah. I don't know how I feel about that one.
Dr. Antonosa.
Yes, I'm listening.
We still have part C of 8.
12. Yeah.
Why? What did I not do?
They want you to compare it when it's a circle.
Yeah.
Oh, when it's a circle.
Yeah, that's what I thought you were doing at the end.
No, I haven't finished. Sorry about that. When is how do we compare this to a circle? We know what the magnetic moment of a circle is. You can do it in 2 lines. What's Matt? What's DL?
What's DL? DL is
No, I don't like when I hear school repeat the question back to me. I immediately don't like the sound of that.
yeah.
It's not Jeopardy.
It's R and then D phi and then phi hat.
Excellent. So DL hat, or just DL in this case, is R D phi phi hat. So if I use this formula, DL dB, just to do it again because it's such an important calculation, believe it or not. DL will R D phi phi hat cross. This is rho hat R. Okay? And the distance from there to there is R squared. This is 2 pi. It looks just like it, except there's a square root of 2 factor, I think, somewhere in there. Okay? So that's pretty easy to do. I actually have it written down on the solutions if you want it. Okay? Let's do the second one. Is the second one's this, right?
Yeah.
I know, but there's another thing I want to show you. Okay? AXI hat plus BXY J hat, correct? It's one of the Maxwell equations. Stuff in your mouth with food. My God, it's like I'm
This is why we said we should take a picture for doing what feels best for
There
us.
are no magnetic monopoles.
What's the mathematical manifestation of that?
Grad dot B is equal to 0.
Very well done. And if we do that, we get I hat partial X plus J hat partial Y. So you know more physics than 6.5 billion people on the planet.
Is there another way? Like, is there another Maxwell's equation we could have used?
I'm going to show you. That's why I'm doing this.
Okay.
Okay, I'm going to show you that in a minute. Actually, it's kind of a tangent to it. But this is the only one. Well, you could, but this is the only one for this. If it makes any sense. So this will be A plus. One of these is y squared, isn't it?
Yeah, B.
Yeah, B is y squared.
It's b y squared.
Yeah.
Yeah.
So that'll be just 2b. This is
Minus
xy over here, or
Right.
I wouldn't get it to be 0, right?
Yeah, XY.
Okay, so this is y, and this is y, this is 0, and then b is equal to minus a over 2, and you're good to go, correct? The next thing he wants to show is what's the current distribution that gives you this. I want to get this on the board because I'm going to use it in a minute.
It's good, right?
Drag cross, you get the current distribution.
You really
from
can't see
another
what he's
one of
writing.
his equations.
It's kind of hard to interpret, but that may just be too small screen.
Maxwell. Drag cross B is
You
equal
go
to
to
mu naught J.
U naught J.
So J is this, right?
Yep.
This is the reason you know that this, when we're about to do the next one, that the magnetic field is perpendicular to J. That's what that tells you. Loosely speaking, of course, you can't interpret this with a gradient operator literally too often. But when you take the grad of something, it's going to be perpendicular. That's how I know the direction in the next problem we do is this way. Now, and I know it's got to be only function of z. Okay? So that's why I wanted to get this up here. So this is I hat, J hat, and K hat. Partial x, partial y, partial z. This is a xy. This is minus a over 2, I think.
Yes.
Y squared. This is 0. And I do this. I get nothing, nothing, and then something. The something's over here. K hat. And I'll get K hat times a. And unless I made a mistake, this is times x. Did I do that right?
Yeah.
So there's over mu naught. There's J.
It's
Is that
negative.
minus?
Yeah.
Is that negative? Okay, thank you. And if you see this thing, notice this magnetic field is in the plane. That's why I want to write this down. This magnetic field has all kinds of vectors. You can plot it. It'd be a pain in the ass, but you could plot it. Was this the class I said I wasn't going to use bad language or math methods?
Math.
No, I never made the
No,
claim.
he never said both. It was just
I
math.
never made the claim that I would go without cursing in this class.
Yeah,
No,
math
it's
methods.
Okay? You can
He's
plot
doing
this
one
thing,
class at a time.
but at the end of the day, any current that gives rise to a planar distribution of magnetic field has to be out of plane.
Wait a minute, say that one more time.
This magnetic field is entirely in the Cartesian XY plane, yes?
Yes.
It's complicated, it's fancy, it has all kinds of,
Yeah.
but at the end of the day, it's in the XY plane.
Okay.
It doesn't have any component in that direction, right?
Okay.
Look at the component, look at J.
It's all in.
It's all in the K hat direction.
So the current, okay, so the current's going up, and the B's, oh, that makes sense, because the right hand roll, it does this.
Oh, because it's current density. The current's perpendicular to B field anyway, so current density is also perpendicular. That makes a lot of sense.
Doesn't it?
The light bulb just went off in
It was
everyone's head.
all worth it. Alright, let's do the next one. So am I making better time so far than you guys? Just slightly. Alright.
Maybe for like 5 minutes.
Yeah, just.
Oh, so we have a question on 817.
Okay.
When you start writing.
Okay. 8-7.